Two sets of stainless steel wires are cut at different lengths, prepared and placed into the protective plastic tubing. Once the wires are prepared, wiring of the crayfish consists of drilling small holes in the gill chamber to span the scaphognathite as well as the thoracic chamber where the wires span the heart. The wires are placed just under the cuticle and sealed with adhesive glue. These wires are then connected to an impedance detector which measures dynamic resistance between the wires in each set. The impedance detector is connected to an analog to digital board, which is connected to a computer. Software provides the gathered data as waveforms that can be collected as beats per minute format for experimental analysis.
Hi, I'm Sonia Bierbauer from the laboratory of Dr. Robin Cooper in the Department of Biology at the University of Kentucky. Today we will be showing you how to record electrocardiograms and electroscagnithograms in crayfish. We use this procedure in our laboratory to record the autonomic response in crayfish in varying environmental conditions. So let's get started.
To begin preparing the recording wires, cut two insulated stainless steel wires to a length long enough to be inserted into the crayfish and adequately reach an impedance detector. Use a flame to remove about 0.5 mm of the insulation on the ends of both wires, which will be inserted into the carapace. Be careful not to remove too much insulation, as a bare wire on the outside of the animal must be recoated to prevent short-circuiting. Next, use forceps to bend the burnt ends of the wires at a 90-degree angle for placement into the carapace. Make sure that the inserted portion of the wire is not too long, as this could damage internal organs. If you are recording both heart and ventilation rates, repeat these steps a second time. Be sure to label the wires for heart and ventilation rate so as not to confuse them. Loosely twist the wires together to make for easier insertion into a protective plastic tube. With the recording wires ready, let's begin wiring the crayfish. To feasibly and safely wire the crayfish, it is best to first wrap the claws and legs in a wet cloth, eliminating the risk of injury to the person or crayfish. Start the wiring process in the gill chamber. Use a fine point scalpel to make the first hole, just large enough for a wire to be inserted under the cuticle in the rostral area of the gill chamber. Once the wire is in place, drop a small amount of fast-drying glue and accelerator onto the wire. Be careful to place only a small amount of accelerator onto the cuticle, since it is toxic to the crayfish. Repeat these steps for the second wire in the gill chamber. These two wires should span the scaphognathite to ensure a strong, accurate impedance measure during each scaphognathite movement. The two wires used to record the heart rate are inserted in an identical way, except that they are placed under the dorsal carapace directly over the heart and span the heart in a rostral caudal arrangement. This placement will ensure a strong, accurate impedance measure during each heart contraction. Once placement of all four wires is complete, mix an instant adhesive and coat the holes and wires in each location. Once the wires and drilled holes are adequately covered, use the remaining epoxy to hold the plastic tubing to the back of the crayfish. This will ensure that the wires are not pulled out of the holes during future handlings. Since the epoxy takes a few minutes to dry, hold or place the crayfish in a container without water until the epoxy is no longer sticky to the touch. Once dry, wash the crayfish in water to remove excess chemicals and place it back in an aquatic environment. To ensure the health of the crayfish, it is best to change the water about 1 hour later to remove any remaining chemicals. Because prolonged handling alters the physiological measurements due to stress, the animal should be left alone for 2 to 3 days before any experimentation. Now let's look at recording the electrocardiograms. To begin recording electrocardiograms or electroscaphognathograms, connect the wires from the crayfish to impedance detectors. The two wires spanning the heart should be attached to a single impedance detector, and likewise for the two wires spanning the scaphognathite. The impedance detector measures dynamic resistance between the two stainless steel wires. These signals are recorded by connecting the detector online to a Power Lab. All events are measured and calibrated within the Power Lab chart software. To begin recording, set the acquisition rate to 4 kHz. The large deflections represent heartbeat and ventilation rate. A smoothing function can be applied to the dataset to simplify counting each heartbeat and breath. The heart rate can be determined by direct counts of each beat over 10-second intervals and then converting to beats per minute. A crayfish that has been allowed to sit undisturbed for a few hours is shown. Normal baseline rates are recorded to show any changes in the autonomic response. By lightly tapping on the tail of the crayfish, a tail flip response is elicited and changes are seen in both the heart and ventilation rates on the computer monitor. Using Power Lab chart software, these responses can be viewed as fluctuations in beats per minute and compared to the original rates before tail flip elicitation.
So I've just shown you how to record the autonomic response in crayfish. So in doing this procedure, it's important to remember to carefully place the wires and let the crayfish sit for a minimum of 2 days. This will ensure that the recordings are due to experimentation and not due to a stress response from handling the crayfish. So that's it. Thanks for watching and good luck with your experiments.